Okay, so we are now talking about the zeros of polynomial functions. So what we're looking at is the rational zero theorem, where if there is a function that has integer coefficients and p over q is a rational zero of the function, then p is a factor of the constant term and q is a factor of the leading coefficient. So to use the rational zero theorem, we're going to list all the integers that are factors of the constant, and then list all the integers that are factors of the leading coefficient. And then we'll list all the possible rational zeros. So it's going to be factors of the constant over factors of the leading coefficient. And a polynomial of nth degree can have roots that are imaginary numbers, and they can have at most n real roots. So let's go find some possible rational zeros. So example 1. So we want to list the possible rational zeros. So we're not going to find all of them. We're just going to find the possibilities of them. And we'll do it for the function f of x equals negative x cubed plus 3x squared plus 4. So we don't care what's in the middle. We care about the leading coefficient, and we care about the constant term. So the constant is going to come up here. So we'll have p and we'll have q. So p is going to be the 4. It is the constant. And the leading coefficient, which is negative 1, will be at the q. So think about, like, this is constant. It starts with a c. This is a leading coefficient, so it starts with an L for the first letter of the words, I guess you could look at. So the 4 will be at the top, and the leading coefficient will be at the bottom. You can think about it. He's already gone past that one, so he's first. I don't know. It's hard. You come up with something where you get it, because I have students who will put them in the wrong order, and then that changes your answers. All right, so when we factor out 4, we're looking for all the factors of 4. So we know that 4 is like 1 times 4 and 2 times 2. So it'll be plus or minus 1, plus or minus 2, and plus or minus 4. You don't have to put them in order, but for most of the numbers we're going to use, you should be able to. You don't have to list the 2 twice. You only list it once. And they have to have a plus or minus in front of them, because we didn't know, is it positive 1 times positive 4 or negative 1 times negative 4 that gets you 4? So you have to list the plus or minus. For negative 1, it's just going to be plus or minus 1. So to find the possibles, it's p over q. So I'm going to take all of these numbers and put them over plus or minus 1. Well, this one's really simple because it's all over 1. So that just means we're going to end up with plus or minus 1, plus or minus 2, and plus or minus 4. So that would be all of the possible zeros. We're not going to find the zeros. We're not going to try them yet. We're just trying to find the possibles. All right, let's go look at another example. So example 2. If we have f of x equals 4x to the 5th plus 12x squared minus x minus 3. So again, we're looking for p and q. So p is negative 3 and q is 4. So plus or minus 1 and plus or minus 3 get us negative 3 when we multiply them together. And 4 would be plus or minus 1, plus or minus 2, and plus or minus 4. So this one will have a little bit more to do as far as finding the possibles. So plus or minus 1 and plus or minus 3 over 1, and that's how I usually do this, is let's put them all over one number, then we'll put them all over the next number. So if we just look over 1, we get plus or minus 1 and plus or minus 3. Now, let's look at it over 2. That would be plus or minus 1/2 and plus or minus 3/2. And then over 4 would be plus or minus 1/4 and plus or minus 3/4. So that would be all of your possible zeros. All right, let's look at example 3. And remember, the order doesn't matter. You just want to get them all. So if we're looking at f of x is equal to 15x cubed plus 14x squared minus 3x minus 2. Again, we want to look at p and q. So p would be negative 2 and q would be 15. So negative 2 is going to be plus or minus 1 and plus or minus 2. 15 would be plus or minus 1 times 15 and 3 times 5. All right, let's go do our p over q. So all of them over 1 would be plus or minus 1, plus or minus 2. All over 3 would be plus or minus 1/3 and plus or minus 2/3. All over 5 would be plus or minus 1/5, plus or minus 2/5. All over 15 would be plus or minus 1 over 15 and plus or minus 2 over 15. And that's all you're doing. All right. So let's actually go solve for 1. Let's go do example 4. So we're going to find the zeros of a polynomial function. So this time, we're not finding the possible zeros, we're actually going to find the zeros. So we're looking at f of x is equal to x cubed plus 2x squared minus 5x plus 6. So we're looking at the possible zeros first, and then we'll figure out which ones are actually zeros. So we're starting again with p and with q. So my p is 6, and my q is going to be 1. So plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 are my factors of 6, and plus or minus 1 will be the factors of 1. So p over q is plus or minus 1, 2, 3, and 6 because they're all over 1. All right, now to find which ones are the zeros, in the past we've done some problems where you're given this one, find it. Well, we're not given any of them. We're actually figured out the possibles. We've got to figure out which one it is. So we're going to use synthetic division to find this. So I'm going to start with, you can pick any numbers. I'm just going to start with 1. So my coefficients are going to be 1, 2, negative 5, and 6. Draw my line, bring down my arrow. So that was 1. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 3 minus 5 is negative 2. Negative 2 times 1 is negative 2. Oh, and yeah, I realize, hang on one second, this should be a negative 6. Sorry about that. So this should have been a negative right here. So negative 6 minus 2 would be negative 8. Got to watch those. I'm not in class, so you can't, hey, that should be a negative. All righty, so did we get a 0 here? We did not, so this is not a 0. All right, let's try another number. Let's try 2. So my numbers are the same, 1, 2, negative 5, and negative 6. Draw the line, let's draw the arrow, bring down the 1. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. 8 minus 5 is 3. 3 times 2 is 6. 6 minus 6, that is 0. So that tells us that 2 is a 0. So let's rewrite the equation. It'll be x squared, remember you drop down a degree, plus 4x plus 3. We'll set that equal to 0, and we can factor that. I'm not going to show you the AC factoring this time. I'm just going to factor it. So x plus 1 times x plus 3. Set each part equal to 0. We get x equal to -1 and x equals -3. So what is our actual set of zeros are going to be the one that we found and then the other two we solved for. So these would be the zeros of that function. So you're going to have to find the possible ones, and then you're going to have to figure out which one it is. All right, let's go look at another example. So we're going to look at example 5. So f of x equals x cubed plus 7x squared plus 11x minus 3. So again, we're looking at p and q. So p is going to be -3 and q is 1. So this will be plus or minus 1, plus or minus 3, and plus or minus 1. So our p over q is going to be a very short list. This would be all over, though just the 1, so plus or minus 1 and plus or minus 3. So let's go find the zeros. So let's start with 1 again. It's an easy number. We have 1, 7, 11, and -3. All right, draw our line. Bring down the 1. 1 times 1 is 1. 7 plus 1 is 8. 8 times 1 is 8. 11 plus 8 would be 19. 19 times, ooh, we ended up with 16. Well, that's not 0, so it's not a 0. Let's try -1. So 1, 7, 11, and -3. Draw down our arrow. 1 times -1 is -1. 7 minus 1 is 6. 6 minus 1, or 6 times -1 is -6. 11 minus 6 would be 5. Uh-oh, we didn't get a 0 again. All right, let's try another one. Let's try +3. So 1, 7, 11, and -3. So 1 times 3 is 3. 7 plus 3 is 10. 10 times 3 is 30. This is not looking good. We're getting 43 times 3. Oops, sorry, 1. 41 times 3 would be 123. Ooh, we got 120. Well, that's not a 0. Let's go try. The only one we have left now is -3. So 1, 7, 11, and -3. Draw the line. We get 1 times -3 is -3. 7 minus 3 is 4. 4 times -3 is -12. 11 minus 12 would be -1. -1 times -3 is 3. Oh, we got a 0. Yay. So now we have x squared plus 4x minus 1 equal to 0. All right. Now, we don't have any other zeros that we can even look at as being the possibility, but we're going to try to factor this. We'll try the AC method. AC trying to get to B, so A times C, that's 1 times -1, trying to get to 4. Well, that doesn't look promising. So 1 times -1 is the only numbers that get you, that's a positive, so we'll put it up, right? But -1 times 1 is -1. We add them, we get to 0. So now we're going to have to use the quadratic formula. Remember, the quadratic formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So our a is equal to 1, our b is 4, and our c equals -1. So x will be equal to the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So -4 plus or minus 4 squared is 16. Negative times a negative, well, no, that part will be positive. 4 times 1 is 4 times 1 is 4 all over 2. So -4 plus or minus the square root of 20 all over 2. So we'll take our square root of 20. Let's factor it down. So 2 times 10, 2 times 5. So 2 times 2 times 5. We're looking for a group of 2 of the same number. We have 2 2's, so that will come out. So we'll have 2 square roots of 5. So let's plug that back in. Negative 4 plus or minus 2 square roots of 5 all over 2. So we need to factor out a 2. Because a 4, a 2, and a 2 all have a 2 in common. So 2 times negative 2 plus or minus the square root of 5 all over 2. Those will cancel, and we'll have negative 2 plus or minus the square root of 5. So for me, you do not need to separate those out. Your answer would then include the negative 3 that you found and then negative 2 plus or minus the square root of 5. That would be your final answer. Now, this is something that can be useful. So Descartes' rules of sign provides more specific information about the number of zeros that a polynomial can have. The rule is based on considering the variations in sign between consecutive coefficients. So it's about how many sign changes there are. So on this problem, we actually go from positive to negative, and then from negative to negative, it doesn't change. The negative to positive to positive, it doesn't change, but positive to negative. So there are 3 sign changes. That means there are 3 positive real zeros, or there are 3 minus 2, which equals 1 positive real zero. So there's either 3 positive real zeros or 1 positive real zero. On the next one, when we look at the sign change, there's from positive to negative and negative to positive, and then it says positive. So there's 2. There are 2 positive real zeros, or there are 2 minus 2, which equals 0 positive real zeros. And then here we have one sign change where it only changes once between a negative and a positive. So that means there is 1 positive real zero. So you can use that as something to look at as far as how many you could be looking for. But really, as you're finding them, you're going to know whether or not you have the real zeros and how those are going to play out as far as what you find by doing the math. But it can give you an idea of what you're looking for. Not a question I would have on the test. I would just have you finding the zeros.